Hey, welcome back to Powering AI with Precision and NVIDIA. I'm your host, Logan Lawler. I lead solutions and alliances for Precision AI workstations here at Dell. And I say this every episode, kind of in jest, but can you believe we're on episode 6? It's like half a year. Like they've actually kept me on camera for almost 6 months, 2 quarters. It's absolutely fantastic. But today, episode 6, we've got a very exciting guest, someone I've been trying to get on for a while and finally got him nailed down. So I want to introduce you, Jags Kandasamy, the leader and CEO of Latent AI. So Jags, tell everyone, introduce yourself, tell everyone just a little bit about Latent AI, and we'll start going.
Thanks, Logan. Thanks for having me, man. It's an honor and pleasure to be on the stage with you here, right? I'm Jags Kandasamy, as Logan mentioned. I'm the co-founder and CEO of Latent AI. This is a second startup in a run for me. I sold my previous company to Analog Devices. Latent AI, we have focused on building a platform for developers to bring AI to the edge devices. Right? Edge can mean anything from a smartphone to a sensor to laptops and desktops and other devices. Right? Anything that has got a compute chip on it, we would like to put some AI on it. Right? So that's the mission that we are trying to achieve here at Latent AI.
I love it. So I know it's been several months ago. I mean, time's all kind of mushing together. But I mean, it was maybe 6 months ago when we kind of got introduced to each other, and I kind of met your team. And there was something that was very striking that I have to kind of tell the story about, which I think is somewhat of a misconception within AI, right? When people say, hey, AI, they really think, kind of an NPU, NVIDIA GPU, et cetera. But they usually equate training, fine-tuning with something very robust. And usually that is very big, data centers running, like PowerEdge 90, what are they, XE9680s or whatever, running a bunch of H100s, H200s. And we all know, because you've been on this webinar for a while, is that we can do, you're not training OpenAI's next, foundational model on a Precision, but you can fine tune one and you can train some smaller models. But what really shocked me about the product, and I definitely want, Jags, after I tell the story for you to kind of explain, but what shocked me was they were like, hey, we can train on a rugged. And to me, if you know what a ruggedized device is, designed for the military, you can drop it, submerge it in water, all that will work. And I was like, so you can really train on something really small like an NVIDIA RTX 500, which is like 4 gigabytes, which that's nothing that I've really messed with up until that point. And that's what I found so striking is the ability to kind of inference, preferably on a GPU, but being able to inference and also train on lower end hardware, but how to optimize for that hardware. So that's what kind of blew me away why Jags is here. But so unravel what I just said, Jags, so everyone understands, because you're much more eloquent than I.
All right. So think about how the training cycle happens today, right? You collect data, you start training, and you try to achieve the utmost accuracy, and you're doing this all in a lab environment, and you're trying to do this. The moment you have something ready, you deploy it, and we've been working specifically with the Department of Defense customers, right? So defense, you've got enterprise training the models, and then the moment you deploy it and it's on the tactical edge, it's gone. If they see something, if something needs to be done, you don't want to stop your operation, send the damn thing back, hey, retrain it for me and send it back. Imagine the time loss.
Right.
6 months. If at the best, it might take 6 months, right? So how do we operate at the speed of a battle rather than at the speed of bureaucracy? That's basically what drove us towards how do we retrain a model at the edge so that it is ready and applicable for the warfighters immediately after. And this can be applicable on the commercial side as well, right? The one thing that everybody knows, a model trained 6 months ago is a stale model today.
Yep.
Data drifts, model drifts happen. How do you keep fine-tuning it so that you are keeping it at the center line? and ensuring that it is producing absolutely the results that you want it to produce rather than results that are no longer relevant, right? That is why this is critical and important, and those are the reasons that we endured on this path, and then help the ones that you guys provided, Logan, providing us with the Dell RTKs, the ruggedized kits, for us to showcase what can be possible.
No, absolutely. And for those that don't know, and maybe your first time in the webinar, it's shocking that a lot of people don't know this, but foundational models, when I say foundational models, I'm talking about, think of your llamas, think of your kind of open AIs, think of your Anthropics, like all these models, right? Is that right now, I'm not going to say impossible because nothing's impossible, but it is almost impossible to real-time train a model because one, you have to get all the data. Two, you got to have the GPU compute power to be able to train. And three is that you need the power to be able to do that. So there's kind of three things standing in the way. So most foundational AI LLMs, or if it's a stable diffusion model, it doesn't matter. Those are not always, but they are going to be out of date. So for example, I've played around and I've done this demo before where I said, hey, which nation won the most gold medals during the 2024 Summer Olympics? And it didn't know. And that's what latent AI is kind of doing, is bridging that gap from that knowledge as something occurs, being able to train a model, not exactly in real time, but much quicker than sending the data back to the data scientist, working through that, and then trying to pass this huge model back. So it's a very, very interesting use case. So you kind of talked about the federal government, Jags. What other industries are you currently kind of working with? And maybe you can talk high level about some use cases that you're seeing.
Definitely. We are looking at manufacturing. We are looking at sports and entertainment. And then we're looking at digital advertising as well, right? I'll start with the digital advertising use case here. Think about, advertising industry has been turned on its head, in the last 25 years through online, right? And as you advertise online on the internet, you get all the metrics that you need of how many people have clicked through it, how many people saw your ad, and all of that. But that does not exist for physical billboards out there.
Right.
Right? You spend a lot of money there. It sits there for months and months. You have no idea how that is turning out for you. So we're working with a partner in putting in a small device with a camera on top of the billboard that's looking down at the road and counting the number of people walking by, the number of cars driving by, to figure out what is my footfall here, right? Some rudimentary analytics coming out through Edge AI, and we're helping them devise the lowest, cheapest processor possible there, the hardware camera combination, so that it can be distributed over. It's a simple function, right? That's your Edge AI use case. The second one we are working with is a company that is trying to build. It's actually doing this they own a lot of sports franchises, sports licenses, and they're doing a bowling lane whereby they're running promotions and competitions on bowling alleys. Okay, in that, whenever there's money involved, there is fraud that automatically comes with that.
Right, of course.
Right. Here, in this case, they want us to be able to help them detect the pinfalls, right? When you say 9 pins fell, actually did 9 pins fall, or was somebody standing there behind and pulling the pins down?
Okay.
Right? Let's say you register to bowl, right, for the competition, and is it actually Logan that's bowling?
Yep. Okay.
How do I do facial recognition? How do I do pinfall recognition all at the edge? And think about this scaling to hundreds of thousands of bowling alleys across the world. You cannot have expensive hardware doing this work. You need a low cost for scalability. That's another example that we're helping.
I love that. I love the bowling alley example. So let's talk a little bit technically, right? So I think everyone on the webinar kind of understands how bowling works, right? You get 2 throws, you're trying to knock down the 10 pins, strike or spare, whatever. But how do you at the edge train it to understand that, hey, the difference between someone knocking down a bowling ball versus, hey, Logan in the back being a cheater using a broom handle and knocking over a couple of pins? Are you training it based on trying to, I mean, obviously it's a bit of computer vision, but like, are you trying to, where did you find people trying to cheat? Do you know what I'm saying? Like, how did you actually train that to learn? Because I would have never even thought of that use case. It's so fascinating.
Absolutely, right. So this is all credit to our partner, right? Like the company that's actually bringing this solution out. They came to us with the problem of like, hey, we've got these things and we need to be able to run it locally because of low latency and
Right.
also from a cost perspective, right? They identified the issues. But again, all of this is anomalies that are happening. If you look at edge cases, right, like in normal software programming, you've got that exception handling that you do.
Oh, yeah.
If your compute goes out of range and stuff, you catch it as an exception and go. There is no exception handling in AI, right? Because if you don't have the right set of data, you're going to miss it. So we are building this anomaly detection engine. Like, let's say you define this as your normal patterns. Anything that goes out of it becomes an anomaly that we are able to capture that and then put that data back into that model training.
Okay.
Right?
So
We've
you
actually
oh, sorry, keep going.
we developed this technology for the US Navy that we are taking and applying to other areas.
That's very cool. So it's really, I mean, I'm going to use a bad analogy, right? But it's really a control line with deviation in and out. And how do you, I'm assuming there's a bit of, I mean, I understand there's the generative part of this, but like, I'm assuming there's some sort of supervised learning in this, right? Because you have to have someone know who is actually cheating and who is actually not to kind of train it. And then if it falls within, I'm just making complete hypothetical, here's a normal frame and it's 5% in and outside of that, you're like, this could be potentially cheating. We don't know, but that's the idea. That's really cool. That's really cool. And then that's the other thing and I understand proprietary stuff, you don't have to share a lot, but the AI and the training, the foundational piece of that is one part, but then how are you integrating that, standard deviation, for lack of a better word, into a program that alerts them that, hey, there might be cheating on lane 6.
That's where our runtime engine comes into play, right? Yep. Think of what Java did for application development back in the day. Latent runtime is doing that. The LRE services that we provide, right? Okay. We are hardware agnostic and we can run any model at that edge. So when we are running it, we are capturing that, and we have services that we enable, APIs that actually plug into the applications that are looking for this information. We have inference as an API, which basically provides a prediction. We have metrics that we pull together. So in the standard deviation thing you're talking about, like how many times is this occurring? How many times is that occurring? We push all that data up through our API for the application to consume. So
that's really cool. That's the first time you've told me about that use case. I love that. That's so interesting. So let me ask you to kind of go, not going to go off topic, but I hope if you're watching this webinar, this one's very different than other ones that we've done, right? We've focused more on, I'm not going to say traditional, but I'm going to say more of the typical, hey, you need high-end precision. Here's what you're doing. This is very different, right? This is very different in what we're doing. Curiosity question, as you run across, regardless of what industries, sports, federal government, Army, Navy, any of that, do people believe what you all do can be done? Do you know what I'm saying? Like, because it's so opposite of what I think AI has been portrayed as over the last, say, 2 years. Like, what's kind of the reaction that you get?
There is a disbelief to start with.
I did not believe it when I first saw it. Like
and then people start becoming believers with a little bit of skepticism, and then once we start showing them, then they become our preachers, right? So it becomes a very a cathartic experience helping people go through that. I'll give you one example here. This is public news, so this is with the Navy.
Okay.
The Navy was trying to put an algorithm for mine detection on an unmanned underwater vehicle.
Okay.
They were struggling to put one model on there for many, many months.
Okay.
They called us, we went and presented. They were like, "You mean you can do this?" It's like, yes. We did it 4 times faster, right? Like running faster, as actually 10 times less memory and 4 times faster.
Okay.
And we were able to fit 4 models in there, not just 1, 4, right? Once we shown that, like, of course, the demo was there first. And then as we went through the contract and we presented, it was an amazing experience. And like the Navy is a bigger supporter for us.
That's a cool story. I know you've told me that one, and I've read that press release. And shrinking of the model is one thing, and I kind of want to switch gears. Another thing that y'all do that I think is pretty unique and interesting, right, is that I think as any industry evolves, right, and we'll just use technology as let's use precision workstations as an example, right? As that kind of market has grown and been established, there's different NVIDIA GPU like benchmarks, right? Like ones that kind of test performance and stuff like that. But and that's the thing with AI models, is there's a few benchmarks and stuff, but there's not really, you've got to it's way beyond my skill set to be able to go out and test to say, well, hey, this one might be faster, but it's a little less accurate. This one's a little slower, but this one's super accurate. And I want you to kind of talk a little bit about, within Latent AI, the model. When I say model, let's talk about different models of precision workstations, but then being able to look at whether it's, foundational LLMs or stable diffusion models or computer vision models, kind of talk a little bit about that. Because I think that is another really interesting thing that y'all do that not a lot of people are doing at all.
Absolutely. I don't think anybody is doing as far as our Intel goes, right?
Right. So, I've seen it a little bit, but not as seamless where it's literally just, it's not that easy for sure.
Absolutely. See, when we started this work, right? Like actually the foundations of this started to happen about a couple of years ago. We started to see the shift in industry where people are struggling. There is so much open source crud out there that you have to go grab it. You got tools, all of this, you're trying to pull it together to make your pipeline work. Right? That's been a huge challenge. And then everybody starts with the model in mind. Nobody thinks about the hardware that they need to run on. Right? So we're like, how do we solve this problem? And we wanted to bridge that. How do you start with the hardware with the end in mind to make it seamless? So we started running models, we started tuning models, and at the same time running each one of those tunings on the hardware that we wanted to run on. For example, the Precisions, the XPSs of the Dell suite that we're working on right now, right? Like we take a model, run it on the hardware, measure how fast it runs, how much memory does it take, how much power does it draw, and what is the accuracy given our data set, right? We measure that, and then we are tweaking. So many hyperparameters that you can tweak. Every time we tweak, we are running this model, running it on device and measuring it. And we've created an automation framework for this. So we can easily pick any model, boom, run it on there, measure the performance, and start graphing that around, right? As you said, if I have one of the examples that I talk about, like you're doing an agriculture use case that you're monitoring a plant for particular changes, and you don't need a very fast model because plants don't grow that fast. You can have a low latency model with high accuracy.
Right.
You can pick a recipe for that. But if you're in an autonomous car or even in a fighter pilot, like where there is a human interaction going on, you need the hyper fast model, but you don't need to be that accurate because even false negatives should be brought up to say like, all right, consider or discard. Mm-hmm. Right? So both ends of the spectrum, right? We can cover all of that. So the idea is not only benchmarking, but also providing a means for the customer to repeat that, right? Most of the benchmarks that you get today are like, oh yeah, we run this fast, and go figure it out how to do that yourself.
Yep.
Instead, what we've done is that, like, with your help, right? Like, we've done this with all the Dell mobile workstations. You can pick any of these computer vision models and run it on any of these Dell workstations just by a click of a button. Choose what your biggest parameter of concern is. Is it inference time? Is it memory? Is it power? Or accuracy, right? Depending on what that is, you can pick, and we can provide you the recipe, and you can build that model quickly.
And that's what I love, right? It's like, it's very much next level thinking that I think if we fast forward a year and a half, maybe a year, 2 years from now, everyone will be doing this. But it is a very thoughtful thing, because you're right. At the end of the day, like the plan example, right, is that if it's looking for, let's say, some sort of, genetic issue or, disease, you want it to be accurate, 100%, because most likely those people are not close to those plants that are growing. You don't want to make a trip out there that's incorrect. But you're right, plants don't grow very fast. But you can kind of pick in terms of what you want. So I think that is kind of the coolest thing. And you're right, it very much flips it on the head. And I've seen the exact same thing, is that usually you're exactly right. It's, I want to run this model, and it's, kind of flipped, where you guys are definitely looking and say, hey, here's my hardware. Here's what you can run based on, do you want it fast? Do you want it accurate? Do you want to suck power, et cetera? Or, in the traditional way, it doesn't do it. And I think where it really flips the paradigm is that getting started in any sort of AI is always a barrier. Where this, with Latent AI, which I think is really cool, is that it's like, hey, bring me your hardware. I'll tell you what you can run. Now, you might not be able to run what you want, but you'll be able to make the most educated guess, or not even educated, you'll be able to get what is going to suit your parameters the best based on what you have. And
exactly.
That's a win. And that's a major win. So, one thing we're going to talk about, we obviously love our NVIDIA GPUs, but also with Latent AI, it's something a little bit different, where you can kind of run any type of silicon. And you made that decision. Talk a little bit about why you did. Whether it's CPU, whether it's GPU, whether it's potentially NPU. Why did you make that decision?
Look, I think of edge as a continuum, right? This is the thought process. I'll have to take a trip down the memory lane, right? Yep. The previous company that I did was, we had automated human hearing, listening to sound, and identifying events from that. We had handcrafted the model to run on an ARM processor. All right.
Yep.
When analog devices came in, they invested money, and the first task that they provided us was, can you run this model on my Blackfin DSP? Guess what we had to do? We had to rewrite every single line of code. Took us about 7 months to do that. And then as soon as we finished, of course, they acquired us, and we all sang Kumbaya. And I stepped out of the acquisition and started pondering around, like, okay, what it is. Then when I joined Stanford Research Institute, SR International, as an entrepreneur in residence to look for my next thing, what I'm going to do as an entrepreneur, I met my co-founder who had built this compression algorithm. Quantization is now standard. Everybody knows quantization, but SEC was the first one to do quantization for DARPA back in 2016 and 2017. Right? He was one of the pioneers in that technology. So I looked at that. I looked at my problem of hardware agnosticity, and that's when we decided, okay, we were going to build a compiler backend that's going to help us scale to multiple hardware. Right? That's one of the core problems. The second one is that, as you think about it, I read this article in Economist back in 2015 around how data is the new oil. I don't know if you remember that article.
I remember that article. Right? Oh, yeah.
Right? So, of course, my little brain goes to the chemistry class in high school where we talk about distillation towers, right? You heat up crude and you get different products at the different layers as you go through the process. Right. That's the exact same thing that came to my mind. Like, okay, data, analog to digital conversion happens at the sensor level. And that data is going to pass through several computing layers, All of them are not built equal. It's a heterogeneous landscape.
Mhm.
How do I apply intelligence at this heterogeneous landscape and extract the right level of intelligence that I need at the right level, right place?
I
So
love
that
it.
led to us being the hardware agnostic. And because GPUs are awesome, NVIDIA is an awesome company, awesome products, but they have limitations of applicability, right? How do we cover the breadth and width of computing available? So that's what we did.
And I love that. And I mean, obviously, I'm very pro NVIDIA, but at the same time, I mean, I'm not going to say an arms race, but there's uncertainty. And I always use this analogy. If you're old enough to remember the Blu-ray versus HD DVD thing many years ago, which one's going to win? You had to have separate. But in this point, what Jags was explaining is this completely different architectures. And there will be, like you said, like these homogenized, systems and infrastructures where it's all got to run. And plus, so I mean, I totally get it. And the other thing is that there's a lot of companies out there that maybe haven't bought a GPU. And if you constructed your product and your toolkits in a way where it only ran off a GPU, sorry,
Yep,
better luck
exactly.
next time. Because I'm curious, have you found for those companies that you work with, obviously they're not small, but there's probably some smaller ones. How many of you actually have you seen come in using kind of GPU, NPU, that type of silicon, and then using you and then realizing like, wow, like we can really take this up a notch in terms of speed and processing power, everything with the GPU? Do you normally see that adoption arc, or what kind of adoption arc do you see, or do you see them already come in with GPUs?
See, with AI adoption, we are still in the early innings, right? Like I would say the early 90s of the internet revolution, right? That's where we are. So there is not quite an arc that can be defined,
Okay.
but there are some patterns that I'm starting to see. People know that scaling with a GPU driven platform is not going to be scalable because they're looking at 1,000 installations. For example, one of the CPG customers that we talked to, they have, let's say, for example, 50 production lines per plant, and each of the production lines have anywhere between 50 to 100 cameras that are running on them, right? Capturing images and stuff. Imagine the cost, and they run hundreds of plants like this, right? Like 100 to 200, 300 plants like this. So if they were to scale an AI solution that they custom built with heavy processing powers, it's going to be impossible for them to scale at the price point that they were given.
Right.
So then they're looking for alternate. Okay, then this is where they're coming to compromise on, like, okay, I don't need to run 17 models here. I can run 7 models at that level, and I can consolidate and run another 3 models in a central location in the plant itself that has some compute there, right? So those kind of design trade-offs people are considering. Then there are others, like mobile workstations, right? Like a subject that is near and dear to your heart.
Right.
Is that like they're like, hey, can I've been using one feed in my laptop to do some work. Can I get more feeds in here? I've got one drone sending me data, and I'm doing some surveillance activities here. Can I get 5 drones so that I can be just me rather than 5 people doing it?
Right.
You see what I mean? So that
Makes sense.
the scalability that way is also coming in.
Yeah, I mean, I agree with the scale, right? I mean, I think as we go and we consolidate, right? And I think the other thing is that, I mean, I think the big thing slowing down, any sort of AI adoption, I think one biggest thing you factored in is scale/cost. That's the absolute biggest one. I think 2 is just security, and not in related to latent AI, but just in general with the not understanding of, well, what was this trained on? Like, where's my data? Like, that whole thing, right? And then just obviously, I think the technical resources, right? At the end of the day, like, yes, I've become more technical in this role. I can do some cool things, but dude, I'm not going out and like training like foundational model. Like I'm not like a data scientist by trade. Like,
Right.
and I think those are the big things that are slowing people down. So, whether it be cost, which we've talked about with latent AI, right? And we've talked about the scale. But let's talk about, kind of latent AIs, the services and the platform. Is it designed? And I've played with it, but I want to ask the question. I kind of already know the answer. But is it self-serve? Is there a managed service? Because that's the piece, is that someone who really makes AI easy and accessible, and I'll use a good example, is NVIDIA's AI Workbench, right? It's a pretty robust tool, but anyone can use it. Like, as long as you have a GPU, you can follow the instructions. It's very easy. You can do some basic things. It's great. How would you say latent AI is set up? Like, is it managed service? Can you manage it yourself? What would you say?
So I would present that in kind of like two to three different ways, right? The classic example that I would give you is Lane AI can be a 747 cockpit.
Okay.
If you want to play with all the knobs and switches and you get a thrill of doing that, and you are an experienced AI engineer that you want to do that, the tooling allows you to do that. The other side, it can become a car cockpit where you have a gas pedal and a brake pedal and a gear shift and a steering wheel. That's all you need to drive a car, right? And then there is the Uber option. You press a button, the car comes, pick you up, and go. Right? So those are the three different options that we provide. So the first one, as I talk about, it's an SDK. Our software development kit can be containerized and delivered to the customers on premise. We don't need to deal with the cloud or anything. They can work on their own environment, data privacy, all of that is given in that scenario. The second part, similarly, we provide recipes in an SDK container that's given to you, and an application engineer who knows Python or C++ can then work on that and work. The third one is the Uber option, which is we've already done all the work. We've created the recipe, and you just click through, what was it, Logan? 3 buttons, and you get a model.
2 buttons.
2 buttons. 2 buttons you click, and you get a model delivered to you as an executable that you just take the code from there, and you can integrate it into your application, and you're ready to run your AI inference there, right? And you mentioned security, right? In all of these factors, we ensure that the data that you bring to the training is secure. And also, when you push the model out, the model in itself is secure. Since we work with DoD, we are, our butts are stamped with the security from DoD. We make sure as we are building models for the edge, we assume that the model is going to be stolen or compromised, right? Like it's going on attributable systems. So you got to make sure that the model is secure. We've secured the model, and we also watermark the model.
Really? Okay.
As we talked about data provenance, we also have model provenance. Is this the model that I deployed? Is this
really?
And you can actually secure the model with your own encryption keys and stuff.
Okay.
Right? So those features, all of that is available through the offering that we provide.
Let me ask a question, because I knew about the encryption. We've talked about that before, but the watermark, I had no idea. Like, yeah. and I've fine-tuned some LoRa's and done some other stuff where I can throw in some metadata, but not watermark in a sense, right? Like, don't give away the keys to the farm or any proprietary stuff, because this is going out to a lot of people, but tell me a little bit more about that process, because that's interesting.
All right. So one of the things that we do is quantization. Mm-hmm. Quantization is where you take a floating point 32-bit or 64-bit and compress it down to 16-bit float or 8-bit integer. Our technology helps us get down to single-bit quantization.
Okay.
We can do asymmetric, right? Like not all layers need to be symmetric.
Right.
Right. We can go down, up and down on the quantization parameters. Okay. The empty spaces allow us to put values without affecting the accuracy of it.
Right. Or the size.
Yeah.
That's interesting.
Exactly.
Okay.
Exactly. So that's what allows us to put in. So from a security point of view, you get that, right? Like you there's no man in the middle attack. then from a brand perspective, right? Like certain companies value, like, they build the models, they put it out there, and anything, the results that come out of the model ties back to the company's brand and position.
Right.
You got to make sure that it is what you put out there that's being used for inference.
That's so interesting. I mean, because that is, the security piece, but also just, I'm going to say the brand values, right? Like being able to say, and I'm going to use a really bad analogy, but let's say large animation studio says, hey, all these wonderful shows that we created for all these children, we're going to let you use their likeness from this AI model. But you're right, because once that thing gets out, anyone can go fine tune it, tweak it, whatever, and then release something on Hugging Face or Cvit AI. Anyone can do that. Hell, I can do that. But I love the idea about the watermarks. And I'm curious how often, I mean, DoD understood, right? But let's say commercial customer. How often does that actually come up in conversation?
There are a few customers that when the model goes into a supply chain.
Right.
There are customers, I cannot name these, right? Like customers that make models that go into other systems, that go into a broader solutioning. They want to ensure that there is no mess ups that happen in the supply chain. There's no mess ups like that. And then others, as you said, like bigger brand value customers, that this is their business, and they don't want any issues with that. So
that's really cool. That's really cool. Well, let me ask another question for you. Like, where do you see? I mean, let's flash back. AI really. I mean, the term AI has been around, but we've went through the machine learning phase, the neural network phase, generative AI phase, probably last truly 2.5 years, let's call it, like from, release of, Chat GPT. Lots has happened in, a few years. Where do you think, and this is not related to Latent AI, this is more just general talk and guess, is say fast forward a year from now, what do you see on the horizon? What has changed over the last year?
Looking behind or looking forward?
Looking forward.
Looking forward.
Now, what's the big thing a year from now?
I think there would be a better way of training these models.
Okay.
We are running out of data to train these models. I think the human species is absolutely capable of anything and everything that we set our mind to. And I think this is a bigger problem that's facing us. AI has proven to be much more valuable, and our productivity is increasing extremely in an exponential manner, right? So in order to keep this going, we need to have better models. And we cannot just rely on data from the past to keep feeding up.
Right.
How do we get over that? Like, one example I normally give is that, like, as a child, if you show a fire to an infant, right? Be it a candle, be it a lamp, something, some flame. If that child touches that flame and knows the heat, the burn, and stuff, that is the only instance that they need.
Right. There's one. That's true.
Only one, right? After that, the flame may be in a candle, the flame may be in a paper burning, it may be wood burning, a house burning. Now they know that it is fire and it is danger. They shouldn't go next to it.
Right.
But imagine how many images of cats were shown to AlexNet for it to determine that.
That's right.
Cat at like 80% accuracy. You see that shift is what needs to happen. I don't know if we will get there 100% in a year's time, but I think we'll make significant progress towards that.
Because I mean, you're right. Like at the end of the day, it's like data is a very valuable commodity, but right, like how many cats do you have to show, or how many, people do you have to show for a recognized person? But I almost think that what you just described, and I love that. I'm probably going to steal that analogy, but you're almost crossing into what I would consider reasoning. In a sense, right? You're almost crossing the boundary. I mean, not completely, but you are crossing very closely to the boundary of, hey, you get burned by a candle. Okay. but like a house burning and a campfire, very different. Do you know what I mean? Very different. Or even you could make the argument a flame on a stove. I mean, you could make that argument. And so do you think in a year we'll be close to that or on the way to that?
I think on the way to that.
Ways out, humbly.
It is quite a ways. So the way I approach that subject is more of a sensor fusion.
Okay.
Right? As human beings, we may see things, but the brain is already processing what we are feeling on our extremities and what we are hearing and what we are smelling.
Right.
The fire is a flame, but you're able to smell the burn.
Right.
You're able to feel the heat.
Yep.
Right? You can feel the crackling sound.
Yep.
Right? All your five senses actually come to bear to create that experience.
Right. Makes sense.
Can we get that going for our systems? Can we get a sensor fusion? It may not be five senses, but can it be, like, for example, in the previous company, we did audio, right? We were helping retiring machinists and mechanics to transfer their knowledge, their decades old knowledge of how to listen to a machine and identify.
Yeah. Engine knocking. What does that actually sound like?
Exactly. Right. So we were able to capture that one form in here. And then now we have computer vision things going on. How do I pair those two? Can I just pair sound and vision together to get certain predictions going or inferences going?
Right. I mean, smell would be interesting now that you say it. Like, how do you quantize smell? But like, you're right. I mean, I think that's a really interesting way to put it. I mean, with sound and vision, you can do quite a bit. You know what I mean? Quite a bit. Feeling would be tough, but that's really interesting. I mean, and I guess the question is that, I mean, that's still a ways out, but as we march towards that, like how much more, I'm not going to say regulations, that's not the right word, but people are worried about AI now. As we move towards that, how much more concern is there in the market? Just generally, or the apprehension around, oh my gosh, like you show it one picture of a candle or one picture of a cat, and now it understands what a cat is. Like, I mean, I won't say worrisome. I think it's pretty cool because instead of me, because I'm in the midst of training a lore for this animation project, like now granted, 1.5 million images running for about 110 hours. If I could get that down to a couple hours, man, I'd already been done with my project. I'd already been done. So I think that's the key. And let me throw you another hypothetical. Is, you say that we're kind of running out of data, which, I mean, data is being created, but, starting today, I think one of the biggest things that we're going to see is that once we have the ability, whether through its, better training methods, like you said, from a kind of a reasoning standpoint, but at the point where what is happening now can be digested and in a model in almost real time or real time, that is going to be, I mean, game changing. Like that'll be a very true inflection point. How far do you think we're out from that? I think at least 5 to 10 years, at least. Maybe I'm wrong. What is your prediction?
No, I would actually push it even further out, right?
Really?
Yeah.
You think beyond 10 years?
Yeah. Think of this, right? Like when we created systems, the output of the system was simply for human beings to consume and to make decisions on. Right? And then we started to try and push the same data back into the machine for it to learn. It's like, I don't know what you're telling me, right? Like the context was not there.
Right.
How do we apply context into every output that comes out and to get back in there? Can you automatically create that context? Some cases it can be done tomorrow.
Yeah.
In most cases, I don't think that context awareness is what will create that intelligent systems. I don't think it's going to happen anytime soon.
Okay. I mean, I can see it right now that you said it that way. I can see it's like, I've got these million images, right? Or over a million images. I still have to caption them. And that takes just as much time, right? And a lot of times they're wrong. So it's like, you have to go through the whole process. Anyways, But no, you're right. Like it is kind of a loop of, yeah, you're creating something, but you also have to provide the context, the captioning, the understanding, the reasoning, and how quickly can you do that? And how better question is, you probably do it pretty quick, but how accurate is it? Because it's trash in, trash out at the end of the day when it comes to AI. So, another quick question for you is that what is a use case within Latent AI that maybe you haven't worked with a customer on, but one that you think would be really cool to work on? I know you probably weren't prepared for that question because I like to throw curveballs.
I see that. I see that. I talk about the sensor fusion, right? From a data training perspective, I would like to definitely work on a sensor fusion use case at the edge. Can I get? We did some work around EO and IR fusion, electro-optical and infrared fusion. That was just from a defense use case perspective. But can I get audio, EO, IR, and maybe radar all put together into a single intelligent system?
That'd be cool.
That would be cool. That would be cool. And doing it at the edge, right? Doing it on a
exactly. I mean, and that's the thing that, I think that's so cool about Latent AI and where I think AI is going is that, like, yes, it's cool to go into ChatGPT, type an answer, but like that was light years ago. It's being able to, in real time, be able to say, hey, I can put this on a submarine and I can detect landmines. Yeah. And I can do that in real time, inference right there on whatever device it is. Or, hey, I'm out in the middle of a forward area and, we know what the tanks look like, but for some reason now the tanks are all painted pink. We can quickly change and refine that in real time, where if you were trying to change your answer in ChatGPT, you're never going to do that. It's like a year old. It's never going to happen. And I think that that's the really cool thing about Latent AI, but just AI in general, is that, I was talking to my mom. I was back, in Missouri visiting my parents over the holidays. And, my mom was talking to me about the job, like what I do and all this. And she's like, I just can't ever see using AI ever. And I go, Mom, and my parents, they're older, they're maybe not, technology savvy people. But I said, Mom, you like to cook, right? She goes, oh, I love to cook. And I said, okay. And I said, how many recipes have you collected from your family, Dad's family, all of our family? She has a huge recipe books, dude. I mean, it's like thousands of recipes, thousands. And I said, how hard is it sometimes to find that one recipe? She goes, so hard. Like, I don't even know what book it is. I don't know what note card. I don't know where it is. And I said, okay, but then you find it, and then you have to then look at it and say that you have to go around to every cabinet and say, do I have this? Do I have that? Or that? Wouldn't it be cool in a system or on a computer, it was looking at the fridge and it could tell you what you had, and then you could just type in, say, cook, my dad's name is Dale, Dale's mother's meatloaf. And it could tell you, here's the recipe, here's all the things you need, here's what you need to buy. And she goes, that would be so great. And I was like, I could build that for you tomorrow. I'm not going to, because you guys don't have internet in your house and it's all dial-up and stuff because you live in the country. Regardless, that's the thing, is that as those type applications, like in everyday applications, start to come through, I think that's when AI will go from, you said, very infancy. The analogy I always use is like, my daughter's 10 now. We're probably about her at 3 months, like 3 to 6 months. Like, we've just started. We're not talking, we're not walking. We're still very dependent on people, me and my wife. So yeah, I don't know. I mean, that's what I think, is I think there'll be more adoption, but I guess, what do you think will be maybe the catalyst for AI adoption? Like, you think about it, right? Like, you go back to and like Henry Ford, right? Go back to Henry Ford, and really the catalyst, there were cars, but it was the assembly line that was the catalyst, right? Being able to produce them out, lower costs, et cetera, et cetera. Like, for AI, like using my parents as an example, what is the catalyst that you think takes any sort of AI adoption from maybe 2, 3, 4, 5% up to 95%? What is that catalytic event?
It's a great question. I'll give one example since you talked about your mom. Talk about my mother-in-law, right? She
Yep.
never knew computers. Okay.
Yep.
We got her an iPad in 2010, 2011, like when the iPads came out first, right? We got her an iPad and showed her things. And she is the most consummate YouTube consumer today.
I love it.
She has learned so many, and it was all her interest, right? Like knitting, gardening, and things like that. She has tried so many new things over the last 13, 14 years because of YouTube, because of iPad,
I love it.
right? The accessibility
Yeah.
and the ease of use. Those are the two factors. How we package it, how we get it to the normal consumer and to enhance their life. Not do something new, but enhance what they're doing. Like exactly the example that you talked about. Your mom loves cooking. How do you make her life easier so she goes and does the cooking part?
Yep.
Right? For like, as we do many things, right? We love 80-90% of what we do in our job, but then there is that 10% that's like horrible.
Yeah. Monotonous,
right?
But
and there are a lot of people.
But you have to do it.
Yeah, you have to do it. And there are a lot of people, we are lucky to have jobs that we love, but there are other people that have 80% of the things is just monotonous for them, and the 20% is what they love to do. Right? Once you switch that scale and give them an automation, the intelligence that does that for them, imagine the productivity that what they do for 20%, if they do it for 100%, imagine, right, the GDP growth, their happiness, right? The human happiness will just elevate so much.
I agree. And I think you're right. I think that, hopefully in my lifetime, we'll be able to see, previous webinar, in webinar 5, we talked about a guy with visual effects, right? Where his job is a lot of rotoscoping, which is like cutting things out, backgrounds and all that. And he said that used to take days and days and days. And now with machine learning tools like Copycat, he said it's like maybe 20 minutes, 30 minutes. Like, you know what I mean? And now he gets to go be creative. And I think that once everyone has that kind of like seminal moment, and I agree. Ease of use, accessibility, like a core use case, that's what'll rocket things. But I still think we're a ways from that.
We're
a ways from that. But so Jags, this was great, man. So we're kind of getting up next to it, like towards the hour. So if you could do your final sign off, and then I'll wrap it up. Kind of where can they find you? Website, socials. Feel free to give your email address. Contact form wherever you want. Final spiel on Latent AI, and then I'll close it out.
Definitely. Thanks, Logan. Thanks for having me. And this has been such a fun conversation, man. I told you we do this more often.
I told you it'd be easy. It'd fly by.
Yeah, I know. It's like almost an hour, right? Like I can't believe it. But this is awesome. So, guys, if you are not an AI developer and you want to build AI models, Latent AI can definitely help you get there faster, right? We are on latentai.com. That's our website. You can send an email to info@latentai.com. It'll come to me. I look at that email as well and tell me, Logan sent you. Happy to get on a call and chat with you. Our goal with the Navy, we help them reduce their time to market by 97%. Just think about that, right? Like 97% time reduction to get to market. That's something that we can help you. And if you're thinking about AI, we can make your AI reality quickly. All right. Thank you.
I love it. Well, with that wraps up episode 6. Jags, thanks for coming on, chit-chatting. Been so easy talking to you. And I love the analogies. It's so great. Like, the cockpit versus the car versus the iPhone. I love it. So with that, we're wrapping up episode 6. Episode 7 will follow. We're working on a guest. So right now it's going to be a surprise, but check out, events.dell.com where you can find the latest webinar schedule for powering AI with Precision and NVIDIA. And with that, I'm going to go ahead and sign off. Until next time, keep your AI sandboxes full and all your AI processing on Precision and NVIDIA.